Alright guys, we're going to do part 2 of our renewable energy sources talk. I'm sorry if you hear some background noise. My kids are in the basement and they are being a little loud and crazy. And I'm sorry for the no webcam. I'm sad that you won't be able to take your awesome pictures of me bending my arm over my head, but I'm talking on my headset mic to try to drown out my children. So let's see how this goes tonight. So we talked about solar power in our last video, and so in this video we want to concentrate on some of the other ways that we can have renewable energy. So remember, non-renewable sources are fossil fuels, nuclear power, oil, coal, natural gas, all those things. Then we talked about solar power in the last episode, and so we're going to talk about hydropower and a few other things in this particular video. So the idea behind hydropower obviously is going to mean water power. So we're getting power from water in some way or another. And typically what that means is that we're using the actual movement of water, whether it's water flowing in a stream or whether it's water flowing in tides, or it's actually water falling, like say down a waterfall or down a dam to produce electricity. In fact, that falling down a dam is probably the most prevalent way that we can get our hydropower. And this is obviously happens all throughout the world. And as you can imagine, if you take something like the Hoover Dam here in this picture here, there's a massive drop there. And so remembering back to your lessons from physics, you've got a massive amount of potential energy, and as you fall down and collect that kinetic energy, you're obviously going to be able to generate a lot of power if you can turn that into electricity. So that's sort of the main source of hydropower. But we can also generate some hydropower from waves and from tides. This is a tidal generator here. This is a wave generator, and they work in the same basic fashion. Of course, you're not going to get that massive amount of energy that you would get as from water falling down a large vertical distance in a dam, but you are going to get a constant motion that whole time. Back and forth, and so in fact, if they've got the turbine set up right, they're going to get the turbine to spin on the forward motion of say a wave or a tide, and then they'll also get another one to turn as it comes on the backward motion as well. And so you can generate power in both ways. And of course, tides and waves are relatively static, and so we're knowing that we're getting that constant motion there as well. Again, not as big a source, and of course then there's the issue of how do we get it from that source to where we need it to be. And of course, if it's in salt water, as they often are, then there's a pretty good chance of getting corrosion, and so you really have to build some very resistant turbines and stuff for that type of power to work. So what are the big advantages? Well, I mean, the biggest advantage is that you've got a pretty good chance to get a really high energy yield, and really it's a pretty large untapped potential. I mean, we do have a lot of dams that we use for hydroelectric power, but probably not as many as we could, definitely. And it's going to yield some pretty low cost electricity compared to say having to do a lot of mining and stuff and actually harvesting everything. Once you build the dam there and get that initial cost, then the cost of the electricity is pretty low. And of course, what's the biggest advantage for us if we're talking about it in an environmental sense? And that would be the idea that there's very little or essentially no emissions out of that. Definitely no CO2, not the same pollutants that you would get from burning fossil fuels. So the disadvantages on the other side here are that we're going to get a massive land disturbance. And when it says the displacement of people, remember when you build a dam that essentially you're flooding the whole area behind the dam. And so you're creating a new lake or reservoir there. And so if there were people there, which there usually are, because most rivers and streams and bodies of water probably have some sort of some people living near them. That's where people tend to live, is near bodies of water. And so the people are going to have to be displaced. In China, they're having a big problem with this now as they build the Three Gorges Dam. They've had millions of people displaced and had to move to other places, and obviously lost their home and maybe where they had always lived all their lives. Of course, it's going to disrupt downstream ecosystems as well as upstream ecosystems. And then one thing that we very rarely think of is that as the reservoirs tend to get sort of shallow, or as the river below tends to get sort of shallow, you can get some methane emissions as the biomass in those areas decay that might not have been there in the same way before. They're going to decay much more rapidly because of the water there. And so you get a lot of methane that way. And remember, methane is actually a worse greenhouse gas than CO2. But again, the level there is probably much lower than the CO2 that would have been burnt. Our second method in this video is wind power. If you remember, what wind power does is wind power is generated by basically differential heating in the atmosphere. And what that means is that we know that the sun heats up different parts of the atmospheres in different ways. Well, what that causes is that you get low pressure areas that tend to be where the air usually was heated up more, and so therefore it's more spread out. The molecules are further apart, and so you're going to get a little bit lower pressure in that area. And then you've got high pressure areas where the molecules are closer together, okay, more dense. Typically that means colder. Okay, and then what happens, the way wind gets generated, is that wind goes from high pressure to low pressure areas. And so whenever you've got these isobars here, these are areas of pressure that we talked about earlier in the year, you've got wind that essentially is going to flow in those directions. Now, of course, you can see this when you see sort of a bunch of isobars real close together here in a low pressure area. That probably means a hurricane or a cyclone of some sort. That's pretty typical of that, but you've got a lot of winds flowing into that from high pressure areas into those lower pressure gradients. Okay, and so that's where we're going to get wind from. And again, while that might not be constant, there's certainly areas that is pretty constant, and that hopefully we can harness that in some way. So how do we do that? Well, in general, we want to build wind farms, and you guys know in general of the idea of windmills, but to really make wind power really sustainable for us, we're going to have to do it on a pretty big scale, and so we're going to need these wind farms. And so you can see some of these here where you've got hundreds upon hundreds of windmills, or maybe dozens of really big ones. You see that we can also have offshore ones as well, which is a pretty good idea if you're, say, in Europe and a lot of your land mass, you don't have a lot of open land mass because you've got a lot of population in a really, really small area, but maybe you've got a sea there that gets a lot of wind that goes through it a lot. And of course the oceans tend to get a lot of they tend to get a lot of wind going through them. Again, partial differential heating of the water, which is flowing, and that's going to set up some wind currents as well. So what are the disadvantages here and advantages to it? Well, I mean, one of the biggest disadvantages, of course, we know is that it tends to be relatively expensive. And again, it's getting cheaper and cheaper. We're making a pretty big push now to try to move a lot more of this into production in the United States, which will make it A, cheaper, but B, help us to build jobs as well. But so why would we want to use it, though? We get really high energy yield. It's pretty widely available. It's pretty low cost, again, just like hydroelectric power. Once it's set up, again, that initial cost is pretty big, but once you get past that, very little emissions. And really, it's kind of easy to expand once you get a couple of windmills set up. If you decide that, your electricity needs have grown and you need to put a couple of more up, that works pretty well. The disadvantage here is really kind of, if you think back to the disadvantage that we had with solar power, this is really a big one here. There has to be some sort of backup or storage, because just like we don't always have the sun out for the solar power plants, the same thing is going to be true for wind farms as well. There are going to be times when the winds aren't there, the winds died down or aren't as strong as maximum level, and so you need some sort of power, some sort of storage way to be able to keep electricity flowing regularly, because you obviously don't want it to be, it wasn't a windy day, I can't turn the lights on, or any of those things. It has to be pretty constant for it to work for us in modern society. Of course, there are a couple other minor details. Some people don't like the looks of them, and you get a little bit of low-level noise from them if you're living close to them. And of course, they can kill birds. That can kind of be mitigated depending on the way that they're set up in the areas that they're set up in as well. Our third type of renewable energy for today is biomass. Now, biomass it means essentially what it sounds like. It's a mass of once living organisms or once living waste matter. So you got plant materials. Typically, we're talking about waste plant materials, at least in many cases, and wastes from animals. So things like manure, that actually in a lot of countries, manure is one of their main sources of fuel. That's what they burn for heat. So that is a biomass sort of thing. They can either be burned directly, so like wood, okay, would technically count as a biomass, and then these animal manures also, those are biomass, and burn them directly. Or we can take plant materials and we can turn them into biofuels, okay? And so what I have down here, these are three sort of examples of biofuels. I know we talked a little bit before about oil algae reactors. This is what's called a bioreactor, and you'll notice there's strands of algae running through here. These are genetically engineered algae that are going to produce oil, actually like petroleum, the same compounds that are in that. Pretty new technology, and it's not very well set up right now. It's not studied quite enough, and it definitely isn't up to the level where we could produce the mass quantities that we need, but we're getting there, and so that's kind of an interesting new field. Of course, ethanol production is a big deal. It's kind of controversial because what's happened lately with ethanol production is that a lot of farmers have switched everything over to corn. And of course, corn, as we've seen in the other parts, is sort of a basic ingredient in most of our food products. And then if at the same time you're trying to make ethanol for it, that drives up the price. That's going to make the food prices higher, and so you have to subsidize more, and then that creates a big mess. So if we're going to replace, say, gasoline or fossil fuels with something like ethanol, which is possible because ethanol burns a lot cleaner than those other things, you're still going to get CO2, but overall it's going to burn cleaner. So we need some other source. Well, a big one, and this is local to us here, is switchgrass. There's a switchgrass plant right down the road in Vonore where they're trying to use it for ethanol production. Bagasse is basically the leftovers from sugarcane plants. This is pretty big in Brazil, since Brazil is kind of the sugarcane capital of the world. When they're done with the sugarcane, this is the stuff that's left over, and they can actually take that and then turn that into ethanol, which obviously is a sustainable thing in all kinds of pretty cool ways, because what that allows you to do is then you're not having as much waste material either. So obviously that's going to be something that we want to be able to do. So that ethanol production is a pretty cool idea too. So what are the advantages and disadvantages? Well, I mean, the main advantage is we want to reduce emissions. If we're not burning fossil fuels, we're not going to be emitting as much. Now, we're still probably going to be emitting some CO2 if we're talking about biofuels, and that they can be pretty high energy yield. And obviously, I mean, we're talking about renewable resources, so I didn't really write this here, but the sort of third bullet point here to advantages would be that they're renewable. I mean, this is something that we can keep up with. So what are the disadvantages? Well, a lot of times, particularly with ethanol production and with biodiesel production, the emissions actually aren't going to be reduced if the way that we produce the ethanol or the biodiesel is through some unsustainable method, meaning that it requires energy to actually, run the plant that does that. And if we do that by running off of electric power that's generated by coal, then we're basically throwing out our advantage there. So that obviously doesn't help a whole lot. A lot of times, particularly in some developing countries, what they tend to do, and this happens in developed nations as well, but a lot in developing countries, is that since they want to do these biodiesel or ethanol type production, is that they actually clear forest areas, particularly rainforest areas, to plant so that they can have these crops. This is also true for oil palms that they use for biodiesel. They clear a lot of area for that. And of course, you're drastically decreasing your biodiversity and destroying ecosystems when that happens. So that's a pretty bad one. And we already talked about the idea that we can increase food prices as well through subsidies on these things. So producing corn to make ethanol is going to drive up the price of corn overall, and basically going to drive up the price of all food for us in this country. A couple of other lower used methods are geothermal energy. Geothermal just means that it's basically, when this says sodded, I have no idea what just happened here with this, but that word is stored in the soil, underground rocks, fluids in the earth. And the essential idea behind geothermal is that we're going to take water, we're going to pump it down into the earth where it's going to get heated up. Typically there would be pipes running through here. They don't really show this. And then run it back up after it gets heated. That heated water, if it's hot enough, it could be used to generate steam that's going to obviously run turbines, just like every other power source. Or we can use this actually in a lot in homes, that it doesn't heat it up to, say, boiling level, but it heats it up enough to do hot water heating or maybe some radiant heating in the floors as well. And so that obviously is going to cut down on heat expenditures too. So that makes geothermal energy, again, lowering emissions and all of those things as well. What are we doing to the earth when that happens? Well, really, this isn't a case like fracking where you're actually, sort of breaking the rocks necessarily and letting stuff back into the pipes, and you're pretty much just running water through in most of these cases for geothermal. So a lot less harmful than that idea. And of course, then you're not pulling up the hydrocarbons. And then the last thing that we want to talk about is hydrogen usage. A lot of people sort of say, hey, there's a lot of energy in hydrogen, and so if we could just burn hydrogen or through something like a fuel cell, then what we would do is we would release those electrons, and that's sort of what's going on in this GIF here. You see that the hydrogen H2 molecules are coming in over here. They're basically going to give up their electrons to become hydrogen ions. Those hydrogen ions are going to join with oxygens and become water. Okay, so what's really cool about using hydrogen in fuel cells is that the only emission that you get if it's just hydrogen going through there is your only emission is water. I mean, what's coming out of the tailpipe is essentially steam, which obviously isn't really going to be a problem. So, I mean, that would work pretty well. And again, this is an example of a fuel cell. And there are some cars in production that use fuel cells. So what So, I mean, this is essentially a really promising sort of fuel source, but there's a really big problem with it, okay? So, the big problem is that we have to produce the hydrogen. There's not much hydrogen gas in our atmosphere, so we can't just sort of harvest it out of there. We actually have to produce the hydrogen in some way, and of course, guess how they produce that most of the time? Well, through electricity. That's sort of the easiest way, is electrolysis of water. That produces hydrogen gas and oxygen gas. But obviously, where do you get that electricity from? If you get that from a non-renewable source, then you're obviously sort of defeating the point there. It has a negative energy yield right now, which is kind of a big problem. Obviously, that's going to lead to some high costs for it as well. And of course, we would need some sort of system to distribute it. Now, what's pretty cool is that what a lot of people have thought about is that we could pair up hydrogen and fuel cells with something like wind power or solar power, that you need a way to store that energy. And that if you could use the solar power to do the electrolysis that would generate the hydrogen, you could then store that hydrogen in the fuel cells. And so even though you're technically getting a negative energy yield out of the hydrogen, you're essentially getting that for free. And so that will work pretty well. So some promise there for the future. A lot of technology still has to be developed that way to make it any sort of cost efficient. Because again, there are some vehicles out there on the road that use fuel cells, but they're not very efficient. And again, you're not going to drive a vehicle if there's no way for you to get fuel very easily, and hydrogen isn't what they sell at the local gas station. Okay, so that was a quick overview of our renewable energy sources. Again, a lot more information we're going to talk about in class, and of course in your text as well. And then we're going to talk in our next video about some ways that we can overall be more sustainable about the way that we use energy.